So 1.5, solving equations and inequalities by graphing. We did the whole Desmos activity on Friday. This is what we're doing again. Okay, we're going to be graphing quadratics, though, some absolute values, some inequalities. So we're going to put more things into it, but it's what we're doing. The reason why you have graph paper in front of you is so you can graph the notes. Okay? So use a graph to solve the equation. Negative 3x plus 20 equals 5. So we're going to make a graph. You guys have your paper. You decide how big you want your paper. I don't really care. Come on. Pen is deciding not to sync up. Yeah, we're going to have a y-intercept of 20, so that's up to you. I'm probably going to count by fives, but...
Wait.
Okay, what did I just make on my paper that you can't hardly see?
I don't even know.
X and Y.
A dotted line.
What are those things, though? What did you just say, Carson?
X and Y.
X and Y intercepts. Or axis, right?
Yeah, I'm going to say they're not intercepts.
No, they are not intercepts. Okay, so we're going to graph these. First of all, we could like set it equal to y and do y equals mx plus b, but we don't have a y there, do we? We have what?
An X.
We have 5. Yes?
Yeah.
So, okay. I don't think I have 20 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Nope. So I guess I'm counting by 5. So if I'm going to count by 5s, that's 5. And so that is a horizontal line at 5. So I'll make a horizontal line at 5.
Ooh.
Come on.
Why is there? Wait.
It's right here. It says 5, yes?
Yeah.
If I cover up all this, that's a horizontal line at 5, correct?
Okay.
So make a horizontal line at 5. Whatever your 5 is, I'm counting by 5s. If you gave yourself enough room to count by 1s, count by 1. And I don't know why it keeps jumping. Maybe I'm going to try the other way.
It does not want to draw a straight line.
It doesn't. It wants to... I'm just going to have to be there. It doesn't want to come clear to the edge. It's having problems. Okay, so that is this side.
Why is it like above the line?
It's... Okay, this is the x-axis, and this is the y-axis. I'm counting by 5s. So this is 5, 10, 15, 20. So it's not above the line, it's on 5. Okay, so now this side over here, right here, is in the form of y equals mx plus b, correct? Okay,
Yeah.
so the y-intercept is what? What? 20. The slope is negative 3. So I'm going to go put a point at 20. 5, 10, 15, 20. I probably should make that another color besides white. Okay, so I have a point at 20, and my slope is negative 3. Okay, when I went by 5s, is that going to be kind of hard to do, go down 3 and then over?
Yeah.
Yeah, but you can do the best you can. Or another thing is I could find the y-intercept and decide where it hits there. I mean the x-intercept, that's the x-axis, right? And what is the y when it hits the x-axis? What is that? 0, right? Is the y 0 at the x-axis?
So we put 0 and X.
So we could plug 0 in for y. So it'd be 0 equaled negative 3x plus 20. Now, if you counted by 1s, can you count down 3 and over 1? Yes, but I didn't do that, so I can't.
Or even 2. You can go down the half.
Yeah. So mine would be negative 20 over 3, negative 3, so that's 20 over 3. So that's about 7, right?
Yep.
So it's almost 7. So it's not going to be exact. 5, 10. So it's going to be like right here on mine. Would it be better to count by ones to do this?
Yeah.
Yeah. Did anybody count by ones?
No.
No. Okay, so now I draw another what?
Point.
Point, and then I draw
A line.
a line. So, is this perfect? Is this great and wonderful to do? No. But it works. You guys do have a straight edge. I'll give you that piece of cardstock, right, that you can use. So you do have a straight edge. So graphically, that's how you do it. But how could I do this that would give me an exact answer? Because right now, if I look at my graph, I'm guessing they meet at 5, 5. What my graph looks like. How about yours?
Yeah.
Okay. But is that, I mean, that's not exact, is it? No.
Yeah,
So,
about 5, 5.
so exactly, couldn't I just solve this for x? Okay, so I would subtract over 20.
It would.
So negative 3x equaled negative 25. And then I would divide by negative 3. So x would...
Miss Mike, if you subtract 20 to 5.
Oh, 15. Sorry. I was thinking 5 was negative. Thank you very much. So subtract, so it'd be negative 15, yes?
Right.
Oops.
You are.
Okay, and that's 5.
I knew something was wrong, but.
Did that work out?
Yes.
Okay. It worked for my x. Now does that work for my y? So if I want my y, I plug this back where? In there, right?
5 equals 5.
So negative 3 times 5 plus 20
15 plus 20.
is 5, which it should have been, right?
Yeah.
Okay, so it worked out okay for us. Is it always going to be exact? No, because when we get harder and harder numbers to graph, it's going to be harder to get an exact graph. But can we do it? Yes. Could we do it with a calculator much easier? Yes. You can tell a calculator to find. You could type this into Y1 and this into Y2, and then there's a button that can find that intersection, and we will do that. But we also need to know how to do it by hand also. Okay, so let's do another one. Oh, things are moving really slow today.
Alright.
Okay, so how are we going to do this one?
Straight line at 3.
What kind of a straight line at 3?
Straight line? What do you mean? What kind of?
What kind? Any line straight.
Like horizontal.
A
Why you
horizontal line. No, on my screen it's not changing. Okay, so you need a horizontal line at 3. So you first need to make your what?
What's on the line?
Your X and Y axis. I think I'll be able to count by ones this time, hopefully. Okay, and then what?
Up 12. No, down 12.
Down 12?
I think.
Okay.
Up 5, right 1.
Up 5, right 1. Okay, now I'm going to tell you right now, when I do these on a piece of graph paper, I will continue to count my slope until I cross that other line. Every single time.
I did.
Because does that show me exactly where they meet?
Yep.
Okay.
Less work.
Yes. And there's no guess to it then.
We're almost done.
Okay, so my solution is what?
What do you mean?
3, 3.
Oh.
And remember, a solution gets written like this. Now, I will tell you that on the Math Excel that we're going to do, oh, not the Math Excel. I thought I assigned a Math Excel.
Nope.
Maybe not.
You're wrong.
Okay, on the IXL, sometimes it just asks for the X. So the answer would be X equals what?
3.
3? But the point is what?
3, 3.
3, 3. The reason why this one wouldn't always ask for a point, does it really already tell you what the Y is?
Mm-hmm.
Yes. Are you good?
Yep.
Okay.
Yeah, it's funny.
Yeah.
It's not switching. Okay. So now we have an inequality. When things, we do need to remember,
Isn't that like everything this way?
yeah, we're going to shade,
Yeah.
but we also have to remember how to graph lines that are inequalities. So first of all, as soon as it will let me draw,
You got the COVID too. It's just COVID.
Then you gotta go home.
You're gonna get me sick.
I'm going to get you allergies.
Yeah. I took my allergy medicine this morning, so I'm good.
Okay, so first of all, if it is less than, greater than, it is a dotted line. If it is less than, equal to, or greater than, equal to, it is a solid line. Correct?
Yeah.
So we just have to remember that. Okay, so first of all, we need our X and Y axis, right?
So the y would be 0. Wouldn't it? No, that'd be x.
No, just
It'd be
slow down. Okay, so we want it when it's greater than 0. That's what this says right here, correct?
Sure.
We want to know when x squared minus 4 is greater than 0. What does greater than 0 mean? 0 is where? The x-axis.
Yeah.
So greater than 0 would be positive. Did we not just spend some time working on where the graph is positive and negative at?
Yeah.
Yes. Okay, so what shape is x squared minus 4? It's a parabola. And more specifically, it's a parabola that moves down 4.
Yeah.
Yes?
Yeah.
So 1, 2, 3, 4. And when we do this, you need to have 3 points to graph,
Why?
at least. So you need to go left and right some. I want to know where it's going to hit, like, what number, I want to know where this hits the x-axis, so that would make it 0, right? So what number squared would equal 4? 2. So if you put in 2, square root 2 minus 4 is 0. So we're going to go at 2, and we get 0, right? What happens if we put in negative 2? All I'm doing, guys, I'm putting 2 squared minus 4 is 0. So that point is 2, 0. What happens if I put in negative 2 squared?
It'll be negative.
It would not be negative 0.
It'd be that negative 2. Though.
So negative 2, 0. So I have a point at negative 2, 0. And then I just need to make my parabola through there, correct?
Yeah. I hate those though.
Make sure it's smooth and not looking like a mountain.
You look like a mountain.
Like this.
Yeah.
Because that would be an absolute value, correct?
But you said you look like
I don't know. I ignored him. Okay, so I want to know, oh, shoot. This is not equal to, yes? So should this be solid?
No.
No, it should be what?
Dash.
Dashed. So the easiest way to do it is you could do that, or you could do it and then go back and erase. But it needs to look like it's dashed. Okay? Now I want to know where this graph is greater than 0.
What do you mean?
Where is it greater than 0? Where is it above the x-axis? Always start where? What's over here?
Negative.
Negative infinity.
Mm-hmm.
Okay, so we're going to have negative infinity to here, and it stops. We're going to have here to here,
Be negative
and it
infinity.
stops, and here to here.
Yeah.
Okay, so where is this above the x-axis?
Negative infinity, -2.
Negative infinity to -2,
Negative,
and,
-2.
nope,
Positive.
Oh.
Yeah.
2 to positive infinity. So if I was going to write the answer, there would be my answer, but I need to shade it on my graph. So that means I shade everything out here,
Not below.
because technically this keeps going, correct?
Yeah.
So all of this would be shaded,
So why would the middle be shaded?
because that's not greater than 0, it's less than 0. Because it's below, the middle is below the x-axis. So that's where, if it's less than 0. If I ask you x squared minus 4 was less than 0, that would be where?
I have no idea. Oh, that'd be the other side.
Not the
Or
other
I
side.
mean that little piece.
Right, it'd be in the little piece under the x-axis.
Mm-hmm.
And that would just be -2 to 2.
Yeah.
Does everyone see the difference between those two things?
Yep.
Okay, so let's do another one. Okay, so I have x squared plus 6x plus 5 is greater than equal to 0. Solid or dashed line?
Solid.
Solid. Greater than means above the
X.
x-axis. Okay, so we're going to start by making our x and y axis, correct?
Mm-hmm.
Okay, that is not in the nice form of ax minus h squared plus k, is it?
No.
No.
It's not.
So it's not helping me out much. So what we can do, because the vertex is HK, correct? That's the vertex?
Yeah.
Okay. So we have a formula that can find H is negative B over 2A. That would find H, and then I could plug it back into the equation to find K. So you want to write that on your paper. H equals negative B over 2A. So this formula is ax squared plus bx plus c.
What
Yes?
is this formula?
This is the h of the vertex. But a quadratic is ax squared plus bx plus c. That's how it's set up, right? So it's ax plus ax squared plus bx plus c. So a's and b's are the coefficients of the variables. So looking at what we have, what is b? 6.
Yes.
So it's going to be negative 6.
Yeah.
And if it was a negative 6, then it would be a positive. Over 2 times a. What's a?
X. Well,
No,
one.
what 1, because it's what's in front.
Yeah.
So negative 6 divided by 2 is
3. -3.
negative 3. So the vertex H is at negative 3. How do I find K? Put it into the formula. So that would be K would equal negative 3 squared plus 6 times negative 3 plus 5. So 9 minus 18 plus 5. So 14, negative 4. So the vertex is at negative 3, negative 4. See that?
Yeah.
So now, is it opening up or down?
It would be opening up.
Up, because it's positive. So negative 3, negative 4, put a point. And we need 2 more points, don't we? Okay, so I don't want to figure out where it's 0. I mean, we can if we want. We do know that the vertex is exactly in the middle, correct?
Yep.
So what I do is I go like 3 to the left, 3 to the right, because it's symmetric, correct? So 3 to the left would be 0, wouldn't it? Okay, so if I plug 0 into the equation, I get 0 plus 0 plus 5, I get,
5.
so 0 comma 5 is 1 point.
That would be 3, 5.
And so if I go 3 to the left, would be negative 6, wouldn't it?
Yeah.
Okay. So if I'm plugging in negative 6, so I get negative 6 squared minus 36 plus 5. Well, this is going to be positive 36 minus 36 is 0, so I just get
Plus
5. And should I know that I would get that? It's symmetrical, yes? And if I went 3 to the left and 3 to the right, should I get the same numbers? Jenna, why are you not writing?
Because I'm not paying attention.
Okay. So, negative 6 and up 5. So, am I ready to draw my parabola? Okay.
Yeah,
Solid or dashed?
solid,
How do you know?
because it's an equal to.
It's an equal to. Okay, so where is this above the x-axis? Over here and over there. So on your IXLs, you'll shade, but sometimes they'll have you write it. So that would be negative infinity to, where's that? Looks like negative 5, doesn't it? Right here? Doesn't that look like negative 5?
Yeah.
Yeah.
Like that?
And then that looks like negative 1 to me, doesn't it?
Yep. To infinity.
Negative 1 to positive infinity. So I'm going to flip the question again. I want to know where it is. Let me change my color. Less than 0. So then less than 0 would be what?
In the U. Or
Oh, not there, not where I just wrote. Sorry. It would be
in the U.
in here. Come on. It'd just be in here. So that would be negative 5. Oops. You can't see it on the graph, can you?
I mean, you can.
Oh, can you? That would be negative 5 to negative 1. Now, this is not parentheses, it's brackets this time. Why is it brackets this time and last time it was parentheses?
Because it's included.
Because it's included. So, what does it mean to be greater than 0? When you're looking at the graph. The graph is where?
Above.
Above what?
the X.
The
axis.
x-axis. What does it mean to be less than 0? Where it is below the x-axis. What if I put like 6 there instead of 0?
You move it up 6.
I would draw a line at where?
6.
At 6.
Then it'd be below that.
So I draw a line 1, 2, 3, 4, 5, 6. So I would draw a line at 6. And it would be above and below that line. Does that make sense, what I'm saying, guys?
Yeah.
So you just graph the left and the right and go from there. We didn't graph the right because the right is 0. Is that our x-axis? Is it already there?
Yeah.
Yes. How do I find the h value of the vertex? What do I use?
The ax squared plus b's x plus c.
Negative b over 2a.
Oh, I said the wrong one.
Okay, so I'm going to go back real quick. If you guys don't have this written, you need it written, and it needs to be like major prominent. Okay, so ax squared plus bx plus c is a quadratic equation, yes?
Yep.
Okay, the vertex, let me write this, is hk. And we find the h with negative b over 2a. Once I have the h, how do I get k? How do I,
Just
once
plug
I
it in.
plug it in where?
The whatever is, I don't know what that is. Ax squared plus bx plus c. Ain't it?
How about that? Okay, once I have h, you plug in h to the given equation to get k. Okay?
Mm-hmm.
And then once you have that vertex, you can pick equal sides on there, can't you? And build your way up. So everyone got it down? Nope, Dylan's still working. Let me know when you're good.
Okay. I got it.
Lily, are you good?
What was
Okay.
the work time today?
Maybe, maybe not. I don't know. There's a lot. I don't want to give you work. I don't want to send you off until you're ready. There's no point. Okay, so I got a left and I got a right, correct? Graph the left, graph the right. On the left, I have a linear equation. On the right, I have a what? Linear equation. So that's what I do. Now, this one is not one that you're going to do a dashed or not, because it's not equal to 5. It's not equal to 0. Does that make sense? We have two equations, so it's kind of weird. Okay, so we got to make our x and y, right? So on the left, what's my y-intercept?
3.
3, and what's my slope?
3 would.
1, right?
Yeah.
Oh, this is going to bug me if I don't do it right. Okay. And actually, I think technically both of these should be dotted as I'm thinking about this.
As I just.
That's okay, just erase it. It's much easier to make it dotted rather than solid, I think. Because in solid, you gotta go right back over it. Okay, now I do have to do the right. So what's my y-intercept?
7.
And my slope
-3/1.
down 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. Can I go up 3?
Yeah.
But then I go left 1, right?
Yeah.
It's a dotted line.
Yep. Okay. So after everyone has it, so I want you to look up here so we can talk about it. I want to know when the left is what to the right. What does that symbol say?
Greater than.
Greater than. I want to know when the left is greater than the right. So the left is my yellowish, right? And my right is my orange. So when is my yellow less than? What does less than mean? Under it, right?
Below.
Below it. So when is my yellow less than my right? Where does that happen?
The left, the like middle of the X.
It right here.
Yeah.
It happens right in here, doesn't it?
Uh-huh.
So in the middle there is where I would shade. Now, I'm going to tell you algebraically how to check this. And I do want you to do it because I think it makes it more solid. What? Yes. You've done this. This is a review. So we need to pick a point out here. We need to pick a point in here and to the right. Because you see those 3 spots? Do you see it can be out to the left, to the right? Well, could it be up here too? Could it be up in the top B also?
I mean, it could.
It could be. So those would be all the sections that you would need to check. Because you could do left, right, down, or top. So we're thinking it's in that middle section, right? Let's just go across, I guess. This first point is at what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have -9, 0. I always pick something on the axis if I can to make it easier. Okay? So I guess we could do this one like up here. Because then you have 1, 0. That makes it easier, doesn't it?
Yeah.
Jenna, open up. And then in the middle I have -1, 0. Up top, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 0, 12. And on the bottom, or on the right, I have 1, 2, 3, 4, 5, 6, 7, 8. So 8, 0. Now, the one in the middle, could I picked a point like on the y-axis also if I wanted to?
You could have done 0, 0.
I could have done 0, 0. I try not to do 0, 0 because it's one of those things that weird stuff happens at it and sometimes we mess it up. So I try not to do 0, 0, but you could have, yes. Okay, so if I plug in -9, so that would be -9 plus 3 is greater than 7 plus 27. Is that true?
No.
No. I don't even have to finish it. It's not true. So you just do that. Okay, so the next one I get -9 plus 3 is greater than 7 plus 3. Is that true?
No.
Is it?
No.
It's not true, is it?
What's that basic one?
Okay. So then,
So it would be up there.
well, we'll have to see. Okay, so then we go to the next one, right? So we get 0 plus 3 is greater than 7 plus 0. Is that true? No.
3 is not greater than 7.
Okay.
I was wrong.
So
I hate that.
then I have 8 plus 3 is greater than 7 minus 24. Is that true?
Yes.
Yes. So it's this one.
This big.
So it's
Oh, you're wrong.
not here. I didn't tell you wrong. I let you say it. Okay, so should we go off what we think or should we test points?
What we think.
Just go what we think. We would have been wrong
Well, what'd you ask, though?
when it was greater than. And I might have asked opposite.
You did.
Yeah, you said less than.
Okay, so
Yeah.
then we're what?
It's up top.
So I had it switched around in my brain, didn't I? I was comparing I think I was comparing the right to the left. But if I just do the math, is that going to happen? No. So pick a point in each spot. Did it take long to do it?
Yeah.
Yes.
I don't think so.
I'm
Because I
not-
really didn't ask you what it was. I just asked you if it was true. I didn't ask you to calculate it. So that would be our solution set. So now I have what? Two what?
Fabulous.
Two parabolas. So I get to graph the left and the right.
Don't blame me. No.
And this says when they're equal, so they're both going to be solid, correct? And that means when they touch, that's where they intersect. So are we going to have shading here? No. You only shade when it's greater than, less than, equal to. Okay. Guys, really the only thing that makes these harder is what you have to graph, isn't it?
Yeah. I guess so.
Okay, so what's my B on this one, guys?
1.
0, isn't it? Is there an X term in there?
No.
No. So this is in vertex form, so it's a parabola that moves down 5 and is skinnier because of the 2.
Yeah.
So down 5. So 1, 2, 3, 4, 5. And this is where you just pick 2 points, make it easy on yourself, okay? So what do you want to pick? 2? Does that work? If I plug in a 2, 2 squared is,
4.
do I need to write it out?
I guess you can.
And we'll plug in negative 2 also. Because they're even distance. Okay, so this would be 8 minus 3. 8 minus 5 would be 3. And 8 minus 5 again, it would be 3. So negative 2, 3. And 2, 3. Okay, this is where it gets really scary because when we do parabolas, is it going to be nice and neat where they meet?
No.
Okay, so then I'm going to graph the right-hand side. Well, this is a parabola that goes up 2 and is reflected down. So 1, 2. And its point, you want to go 2 also?
Sure.
So if I plug in 2, so negative 2 squared plus 2, and negative 2 squared plus 2.
So B, negative 4 plus 2 is that
So negative 4 plus 2 would be 2. It would be negative 2.
Negative 2. The first one would be.
And this one would be negative 4 plus 2, so it would be negative 2 also.
Yeah.
So 2, negative 2. And, or negative 2, 2, and 2, negative 2.
Crosses in 2 places.
Does cross at 2 places. It crosses here and here, and I don't think I drew it exactly right, do you? Because shouldn't they be like
On
no.
1 and -1? Like, shouldn't these be symmetrical? Yeah. So that's not exactly. This one looks like -1, 0 on the left, doesn't it?
Yeah.
And on the right, it looks like 1.5 and -1/2. So, are these perfect? No. Did we graph their solutions? Did we? Okay. Could we also do this algebraically?
I mean, we can, but.
Okay. No, we're going to. Okay. So if I have this algebraically, I have to move things left and right. Yes.
Yeah.
Sure.
So I would add x squared,
Yep.
and I would add 5. So that gives me 3x squared equals 7. And then I would divide by 3.
Yep.
So x squared equals 7 over 3. And then take the square root. So x equals plus or minus the square root of 7 over 3. So which one's probably more right? That one, right?
Yeah.
Because
Yeah.
-1, 0 would be nice, neat numbers, wouldn't it?
Yeah.
Okay, so algebraically, do we get a more exact answer?
Yeah.
Yes. Okay, so you have an assignment. It is page 45, 9 through 29. I'm talking, Dylan. Sit down. Sit down. Okay, you're going to need probably a piece of graph paper, unless you have your own. So I would take one, because it's going to make you graph it. Okay, so if nothing else, you should have what when you walk in tomorrow? A bunch of what?
Questions.
No, you should have a bunch